This is a wave machine. It's a device I really like using in the classroom, not just because it's fantastic for demonstrating wave phenomena, but because its construction is obvious so students can see how it works. It's cheap to make and it's really pretty. As you can see, it's made of 3 components: kebab sticks, jelly babies and duct tape. It took me about 15 minutes to build this, but I reckon if you've got someone helping you, you can do it in around 5. Now obviously you could build it in advance, but you could also build it as part of your lesson, or perhaps even get students to make their own. A few things to bear in mind. The tape needs to be in tension, so it needs to be attached to something rigid, and I'm using these clamp stands attached to my bench using these G-clamps. The spacing of the kebab sticks isn't critical, but they do need to be roughly evenly spaced, and I'm using a gap of about 5 centimeters. You can make a slightly more robust and reusable version by just running another length of tape along the top. Now the one problem you will encounter is that as you're building the thing, it tends to get lopsided, but you can easily solve that by simply sliding the jelly babies along the kebab sticks. So that's how you build a wave machine. Let's see what it can do. I think it's best to start with a single pulse, which you can generate like this. Now you can see that there's a disturbance which travels gracefully from this end of the machine to the other. And the key thing to emphasize is that you can see the jelly babies moving up and down, but they're clearly not moving through the machine. It's the disturbance that goes from this end to the other. So how does that work? Well, when I lift this jelly baby, it causes this bit of the tape to twist, which twists the next bit, and so on along the whole length of the tape. So it's the twist that is moving through the tape. What the jelly babies do is add mass to the system and slow the whole thing down, making it easier to see. So in effect, what I'm doing is putting energy into this end of the machine and seeing it transferred several meters along the machine by the disturbance. I can change the amplitude of the wave by simply lifting the jelly baby higher to begin with. Now, notice that that doesn't change the speed of the wave. If I jiggle the jelly baby up and down more quickly, I should get waves of a shorter wavelength and a higher frequency. And again, notice that that doesn't change the speed of the wave. We can change the speed of the waves by changing the machine. So, I've removed the jelly babies from just over half the machine. Now watch what happens. What I hope you saw is that as the waves cross the boundary from this part of the machine into this one, they speed up, just like light waves speed up as they move from glass into air. So there you have it, a wave machine made with jelly babies.